Okay. Okay, very good. Welcome. We will get started in just a few minutes, ladies and gentlemen. Um, Good afternoon, Mr. Ristrianta from Indonesia. Very warm welcome to you, sir. Thank you for making the time. Thank you for joining. Everybody, as you can see on your screens, our two speakers, Dr. Hans and Joseph, are here already. All three of us are very excited. We are, waiting to start the event. We'll just wait for a few more minutes because we had a lot of registrations for this event. So we are just waiting for the room to fill up. Mr. Vinay Jadhav from Midcon is here. Good afternoon. Welcome. HRG Solutions is here from Delhi. Good afternoon and welcome. Good to see you. Requesting the participants to please keep your videos off. That will enable you to get the most out of this webinar. We'll get started in just 2 or 3 minutes. Again, in case if you would like to introduce yourself in the chat, Dr. Sundaram is here from JPMA, one of the world's best known authorities on the sugar industry. It's an honor for us, sir. Very warm welcome to you, Dr. Sundaram, for making the time. It's an honor for us that you have come. Mr. Prateek is here from Protos, Mumbai. Hello, Prateek. Good afternoon. Thank you for joining. Mr. Padam Bihari Dubey, namaskar to you too, sir. Good afternoon. Thank you for coming. Very warm welcome. So we are approaching very close to the start time. Maybe in just 2 minutes from now, we can start. Till then, if you'd like to introduce yourself, please feel free. Good afternoon, Avinash Bhatt. Avinash, if you could just tell us your organization, that would also be helpful. A very warm welcome to you. Thank you for coming. I see some participation from Gem Sugars. I see some from Uttam Sugar. Thank you for coming. It's an honor for us that all of you have made the time. Mr. Samir is here from Toyo Engineering. Good afternoon, Mr. Samir. Warm welcome to you. Mr. Avanish is from Bajaj Hindustan. Good afternoon. Thank you for coming. So the room is getting full and we had a lot of registrations for this event. So I'm just going to give it maybe 1 more minute in case somebody is running a little bit late. Mr. Dayanandan is here, formerly from National Federation, and also he was the managing director at Jamkhandi Sugars. Good afternoon, sir. Thank you for coming. It's an honor for us that you've made the time. We are very excited. Thank you. We have somebody from Brazil. Hello, Edelcio Moraes. Very warm welcome to you. Thank you for coming. Gosh, I don't even know what time is it in Brazil. So we really appreciate you, getting up, I suppose, really, really early. Thank you, Edelcio. Thank you. Okay, so I suppose it's nearly 2:05. Let me start the event. It's not. We have many guests. Okay, so again, welcome to the Shriji Biogas webinar. My name is Sachin Agarwal. I am the CEO of the Shriji Group. Just a quick housekeeping rule. Please use the chat box to ask your questions. We will answer all the questions at the end of the presentation, and both our speakers are happy to answer your questions. but we request you to please use the chat box. A quick introduction to Shriji. Shriji was established in 1976. Shriji has 46 years of experience in the sugar industry. We design, manufacture, and supply turnkey raw sugar mills, refined sugar plants, and now, in collaboration with JNF Biogas, we are also offering turnkey biogas plants. Shriji has a vast experience of doing turnkey projects all over the world. We have clients in 30 countries, 30, and I'm delighted to see some of our clients and many participants from those countries over here. Shriji as a company is always looking for new ideas and new technologies to serve our clients. After a lot of research, we came to the conclusion that biogas from pressed mud or filter cake can be highly profitable for the sugar industry. When we did some more research, we found out that the world's leader in biogas is Germany, with approximately 10,000 biogas plants. So we were looking for an experienced biogas technology partner from Germany. And that is when we came across JNF Biogas, which was started by Dr. Hans and Joseph. So today, Shriji is offering you a complete biogas solution with German technology and Shriji project execution. Shriji will take the order and design and supply the biogas plants based on JNF's German technology. About our two speakers for today, I'm absolutely delighted to present to you Dr. Hans Friedman and Mr. Joseph Arulappan. Let me introduce Dr. Hans Friedman first. If Germany is the world's leader in biogas technology, then Dr. Hans is the biogas leader within Germany. Dr. Hans is one of the world's most experienced and knowledgeable biogas professionals. He has more than 38 years of experience in biogas plants design, construction, and operations. Dr. Hans has worked with many different feedstocks, and most importantly for us, he has experience of pressed mud as a feedstock. Today, there are more than 100 biogas plants all over the world which are working on Dr. Hans's proprietary design. He is also a past vice president of the German Biogas Association. Dr. Hans, thank you so much for making the time and a warm welcome to you.
You're welcome.
I would next like to introduce my good friend Joseph Arulappan. Joseph is a co-founder of JNF Biogas. He has 13 years of experience in clean technology with a focus on biogas. Joseph is an engineer. He also has a master's degree from Sweden. Joseph is very familiar with the Indian sugar industry because just like me, he also comes from a sugar family. Joseph's father is a very well-known and well-regarded sugar technologist. Joseph, thank you so much for coming and welcome.
Thank you, Sachin. Thanks for your kind words.
Lastly, before I turn it over to Joseph, please feel free to send Shriji your inquiries related to biogas plants. Our sales team is happy to discuss it further with you. We can be reached at sales@shriji.com. That's sales@shriji.com. So with that, I hand it over to Joseph. Joseph, over to you, my friend.
Thank you, Sachin. So let me share the presentation. You are able to see the screen, right? Okay. So yes, Sachin, thanks for the very kind words and introduction. So I would just give a short agenda of this presentation, like, what would be the kind of this presentation flow, just to give you an idea of what we'll be discussing today. So we would start with the basic introduction about what JNF is offering in terms of technology, and also a little bit about more to keep it very simple on the basics of biogas. For example, to starting with the Satat scheme. Satat scheme is something which has been introduced into the India for setting up these biogas plants by entrepreneurs and sugar mills. So I'll go through some details on Satat scheme, and also what are the different feedstocks which can be used from the sugar industry and the non-sugar industry for setting up this biogas plants, and also a little bit on the gas yields, what would be the gas yields from different feedstocks, and also on different components which are in biogas, because biogas in India is not something new, but we not had many industrial scale biogas plants. We had small gobar gas biogas plants in India in the past 40, 50 years, but to scale it to up an industrial scale, there are different set of components and skills needed when setting up this biogas plant. So I would also go through this different components in the biogas plants and what are the technologies involved in this and so on. So first, I would start briefly by giving a short, presentation on the technology, what we are offering here in cooperation with Shriji here in India. So we call it as something called a semi-dry fermentation technology. There are many fermentation process, but just to simplify it, in this process, which was developed by Dr. Hans back in 2002-2003, the process works in a way that there is a minimal water requirement for feedstocks like press mud when you do the digestion, and also as a result of this, you have the lesser digester size, a compact digester compared to other technologies in the market. And what would be the advantages? So one might ask, what are the advantages of offering such technology? So the main advantages would be like, your power consumption would be typically lower than a conventional process, let's say other process, and then your digester footprint will be lower. And also in the Indian context, many of the sugar mills don't like having liquid in their premises, the sugar mill premises, from the past experiences of handling spent wash or vinasse. So, this specific process, when you're using press mud as a feedstock, also reduces the, the slurry coming out. The dry matter is high that, you don't kind of, get the slurry. So this can also be the digestate coming can be disposed of easily. So this basic about the technology. So I would not go much into the technology part for now. So I would move on to more on practical issues, what is available currently in the market on terms of the scheme. So Satat scheme, as some of you would have known, this is something called a sustainable alternate towards affordable transport. So this was launched by the Indian government back in 2017, 2018, and with some amendments, it has again reintroduced back in current year, 2022, with some, the central finance was reintroduced back. So this was the scheme which was basically, with the Indian government introduced for the entrepreneur sugar mills to set up compressed biogas plants, where the investors or operators can set up these biogas plants and sell the biogas or the CBG to the oil marketing companies. So the CFA, there is something called a central financial assistance for setting up these biogas plants also. The reason is I'm just starting to give an idea of what is the scheme and what are the advantages, or what are the contents of this specific scheme introduced by the government. So if there is a sugar mill, or if there is an investor or an independent operator or an energy company who wants to set up a biogas plant, the central government via its agencies who are responsible are offering close to 4 crore Indian rupees for setting up a 4.5 ton output of CBG or a 4,800 kg of a CBG plant. So in terms of press mud, if you would ask what is the size of the plant, this would be roughly 125 ton of input press mud capacity plant per day. When you're having 125 tons of press mud input, you would have around 4,800 kgs roughly. So that is around 4 crore Indian rupees. And when it comes to an existing biogas plants where you can generate biogas and convert that into a CBG, then they are giving around 3 crore Indian rupees for setting up such plants. And the maximum central finance currently available in India is around 10 crore Indian rupees. That's around 1.3 million US dollars, around that, for our international participants to know. But I'm sure that in some other countries also there are similar biogas policies which can be, there might be central financial assistance which can be used for setting up these plants. And also when it comes to the gas offtake, because that's one of the important things, once you set up a biogas plants, how do you sell the gas generated? Because most of us in sugar industry are used to, now used to ethanol being sold or taken by this oil marketing companies. So the government has made a provision where the oil marketing companies would be involved in buying the gas from the producers of this CBG. It might be a sugar mill or independent operators. So they set up a pricing slab for buying these different different prices based on the nearest CBG or let's say CNG station. So they benchmark the CBG price against the CNG station. CNG is like compressed natural gas stations, which is quite common in most parts of North India. Let's say in UP, Delhi, and Haryana. Also now it's getting more like popular in South as well. Like where there are a lot of gas pipelines being set up. So the government has benchmarked the pricing sales price against the sales price of CNG. So you can see that the base price, including with GSTs or GST is around 56 rupees, 56.7 Indian rupees for sale offtake of this gas. And depending upon the CNG price, as I said earlier, the price kind of increases. So the formula is that roughly they are offering a 20% lesser than what is there to the nearest CNG station. And there is also a pricing offered on the distance base also. If the CBG plant is away from the sale point or where you have to sell it, there is also a pricing based on this or this specific criteria as well. So this is something which the government has reintroduced with some refinements to encourage more entrepreneurs to set up these plans in 2022. And this is something all the interested investors should make use of, because as of today, this is existing. The subsidies would exist until 2025-26. So who are the first movers in the market would be able to take advantage of this specific assistance. And then when it comes to next, I would just briefly go through different feedstocks which are used for biogas. Like cane leaves, paddy straw, pressed mud, napier grass, bagasse. These are like common feedstocks available. Of course, each feedstock has its own kind of characteristics when it comes to digestion. They have their own gas yields. They have their own type of characteristics which give the corresponding gas yields. So in sugar industry context, cane leaves, pressed mud can be used, and non-sugar like even bagasse can be digested, but bagasse is slightly challenging compared to pressed mud or cane leaves because of the content nature of lignin content in it. So the low-hanging fruit in the sugar industry would be like pressed mud, and then cane leaves also something which can be explored because there is a lot of cane leaves also which is left behind in the fields post the harvesting of the cane. And paddy straw is something, as we all know, that in India there is a lot of pollution issues in Punjab and Delhi and Haryana regions when it comes to harvesting time during the end of the year in November and December. So paddy straw is also being used as an interesting feedstock currently by many investors who are setting up large-scale biogas plants. So now I would just jump into explaining a very basic anaerobic digestion process. How does the process works? I mean, most of us know how the process works, but just for the audience, who are perhaps new to biogas, to go through, how digestion happens and what are the end products which are obtained post the digestion. So any organic matter, depending upon its nature, can be used as for digestion purpose and to generate biogas. So livestock, cattle dung, energy crops, you can use from STP sewage plants, you can use from hotel restaurant waste, supermarket waste. Of course, the industrial waste, what we are discussing today would be more on pressed mud and cane leaves. And so different kinds of energy crops can be used, and also other substrates can be used. So even a co-digestion can be also made in a single digester. But the most important first step is to understand each feedstock, analyze its characteristics. What are the characteristics in terms of the dry matter, organic dry matter, the digestion capacity, and so on. So digestion is basically a fermentation process. It has, of course, in industrial scale, like many mechanical components, like agitators, mixers, heating systems, and other components which are involved in an anaerobic digestion process. So we will go through this some of the components in detail at the later part of this presentation. So the gas generated, again, raw biogas is around has a methane percentage around 50 to 55. It depends upon the feedstock, and each feedstock has a specific biogas yield. So and then CO2 and other components. So based on the requirement, if you're generating heat, thermal applications, or you're using for electricity generation, or in our case, in Indian context, biomethane is a more interesting aspect which is being currently used in Indian context. And also it can be injected into the gas grid as well. For example, it can be taken into the gas grid. And what are the organic manures generated, you can see that fertilizer, a lot of organic manure comes out post the digestion in form of, because whatever we are loading into the digester, there is a specific percentage which gets converted into biogas. The rest of the inorganics and organics generated post the digestion comes out in form of a digestate, which can be further processed into an interesting organic manure, which can be used as a replacement for chemical fertilizers in what currently we are using for various crops. So this is a typical biogas composition. So the methane would be between 50 to 60%, carbon dioxide in the range of 40 to 50%, and there are traces of other gases also which are present in the raw biogas. And as I said earlier, the gas yield and the composition would vary from feedstock to feedstock. So that's why we always insist on to understand the feedstock characteristics. Even if you take press mud, there are different quality press mud analysis we have come across in India and also in other countries. So it's very important. The first thing is to do a standard testing of the characteristics, and perhaps followed by a biomethane potential test also to determine the exact biogas yield before starting a biogas plant. So this is a little bit more about what are the different feedstocks and their gas potential. So we have our team in Germany. Dr. Hans and his team has worked in Brazil, mainly in the sugar industry. So they have a lot of experience of working on different kind of feedstocks and also seeing the gas yields. So this is just an idea on what the different gas yields from different feedstocks. Cane leaves, as we discussed, is one of the potential feedstocks. Cane leaves gives a little bit higher gas yield because it has an organic dry matter of around 94% and dry organic material around 96. So the yield is around 356. That's based on the specific characteristics of cane leaves which should have been taken there. So then there is cane tops. As we know that cane tops is also something which comes out post the harvest. We can use the cane tops, and the same tops can be made into a silo. Silo means you make it into smaller sizes and store it for a usage for a longer period of time. And then you have sugarcane silage as well. Sugarcane silage is like, our team there has tested even the sugarcane, the direct sugarcane without taking it for sugar production. I know that most of you would not like doing that, but even the biogas yield biogas has been tested based on this as well. And then filter cake, fresh filter cake and filter cake silage also has been tested, and you can see the gas yields here. What are the different gas yields which are being used here? And then we have bagasse also has been tested under the Brazilian conditions. And most of the numbers here, we have also kind of worked on Indian numbers. So in Brazil, what happens is the sugar mills, some of the sugar mills are little efficient, so that, the gas yields is slightly lower, because when the sugar mills are less efficient, so the gas yield also change correspondingly. So this is one of the first plants I would say in the world, which was set up using press mud in Brazil back in 2010-11. So Dr. Hans and his team have been part of this project with their local investor there. So I would let Dr. Hans to discuss or present more on this experience from this specific plant. Over to you, Dr. Hans.
Thank you, Joseph. That's one of the first plants. That's the first plant in Brazil, digesting press mud. The plant was designed for about 400 tons press mud per day. The blue container there are CHP from Germany, MWM, 2 machines, each 2 megawatts. So in total, the plant had an installed power of 4 megawatt. 2 digester, 5,000 cubic meters each to produce the gas for the 4 megawatt. This was a wet digestion plant, the first one to test the digestibility of the press mud and the vinasse from a sugar plant there. Could you take the next slide? Yeah. We tested the filter cake, the press mud. In Brazil, it's called torta. We made some tests with bagasse, with vinasse, with cane leaves, and even with a mixture of these feedstocks in this wet digestion plant. To be honest, the mixture failed. It was very difficult to handle all these different materials on account of the difficult viscosity in the digester. We made the design of the plant, of the process. My job was to train the team in the operation of the plant and to help in the startup and the biological service of that biogas process. One point was the process needs micronutrients to work in a stable way, for example. Next slide. Yeah. Joseph, would you like to go on?
Okay, sorry, it was on mute. So the next slide would be on the co-digestion of sugarcane industry waste, because we always have so many questions in the Indian sugar mills, like what would be the combination, what kind of feedstocks can be used in here for co-digestion as well. So based on the past experience and also looking at the feedstock analysis, substrates like press mud and cane leaves can be co-digested. Because these are more on the dry matter is, for example, press mud is more than 25% and cane leaves also on higher side. So these are both, you can technically term them as solid feedstocks. So the solid feedstocks can be used together. And then we also have seen many cases where there is a common inquiries on how if press mud and spent wash can be co-digested together, what would be the process, what would be the end result, and so on. So our experience mainly from Brazil on the technical part, it is feasible to mix press mud and the vinasse or the spent wash, as we call it in India, the gas generation and all those factors. But in Indian context, what we see as some of the challenges is mixing press mud and spent wash. There are certain pollution control norms in disposal of spent wash in general, as we all know from the sugar industry that the pollution control board is very stringent when it comes to the spent wash disposal, even from the distillery. So once you combine this, there are certain regulations, rules, the disposal guidelines which have to be followed. So that is one thing which is to be addressed. And then the solid liquid separation of spent wash and press mud once digested is also one of the, I would say it is feasible, but again, you need to put decanters, solid liquid separators. And again, there is a slurry coming out in form of, which is mainly the vinasse or the spent wash. So how to handle it, further process it is the main challenge. And also when it comes to press mud and spent wash, the sugar mill crushing season is in a way that, you have press mud generated at one point of time and spent wash generated at another, not another, but maybe nowadays the ethanol plants and the alcohol plants, they run a little longer, close to 10 months compared to the sugar mill running season. But the main thing is some sugar mills want to use press mud during the season and some use the spent wash during the off season and so on. So changeover between spent wash and press mud would take some few months, like 2-3 months to stop and start. So these are some of the challenges where you will have some of the downtimes and the sludge accumulation and a lot of things which might one could foresee while mixing these specific feedstocks. So what we would normally advise is to digest the solid and the liquid substrates independently, so they work on an independent basis. And also that you never know with the spent wash as a slurry coming out, we never know when the government would have restrictions on stop generating them, because most of the UP mills, as for according to our understanding, they don't generate any more spent wash. Most of them incinerate this into the boilers, and then we have a press mud separately digested would be one of the better options. This is a basic process flow of digestion process. This is very simple process flow. We wanted to just share to see how this process would work. So this is more for the solid feedstocks like press mud. So we have press mud, which is being taken from the storage yard and loaded into the feeding system by using a teleloader type equipment. So we don't mix it with water and pump it into the digester in a specific ratio. So in our specific process, we would prefer to take the press mud directly into the feeding system in the solid form and then take it into the digester. So the digester has a gas holder on the top where it can be used for gas collection, and the digester again has agitators inside the digestion system, which we will show some of the pictures in the following slides. And then we have other components like instrumentation, electrical and everything, of course, which all comes as part of the package. And then post the digestion, we have the digestate, which comes out as an organic manure. The raw gas typically has hydrogen sulfide and CO2 also present in it. So for making a CBG, compressed biogas with a high pure methane quality, we need to remove the hydrogen sulfide. The hydrogen sulfide in press mud varies depending upon if the sugar mill is a sulfitation, uses a sulfitation or a non-sulfitation process. So it can be anywhere between 500 to 5,000 ppm. So based on the characteristics of that specific mill, suitable hydrogen sulfide system can be designed. And then you have a CO2 scrubbing system followed by the hydrogen sulfide, because the hydrogen sulfide is highly corrosive. So we need to remove this before taking this into a CO2 scrubbing system. The CO2 scrubbing system, there are few 4 to 5 different technologies which can be used for CO2. Again, we will go through briefly in one of the following slides. And post the CO2 scrubbing, then we have purified gas, and then which is compressed into the cascades at a 250 bar pressure for further transportation to the oil marketing company's depot, or it can be used as a vehicle fuel. But again, currently there are also provisions of selling independently. It's not that you have to only sell to oil marketing companies. The good thing about biogas in comparison to ethanol is that biogas can be sold independently to hotels, restaurants, the compressed gas with a little bit higher price as well. So the importance, the next slide would be very important, because we have questions on, our sugar mill runs only for 120 days, 250 days. How do we operate the plant? So the sugar mill crushing season typically varies between 120 to 250 days across the world. I mean, just an average number. So the biogas plants need to be operated for 365 days in a year. So starting from the season until the end of the season and during the off season as well. So this is a continuous biological process, which means that biogas plant has to be operated for 365 days. So it's very important to store the press mud for the off-season operations. So we get questions on how do we store press mud? How does press mud can be stored? So this is something, what you see is a press mud storage yard from Brazil, which is used for storing the press mud. So here what you see is the different compartments or bunkers where there are partition walls, and the biogas here is compressed into form of where we use some small tractors and vehicles for compacting this, so there is no any reaction happens. So before setting up a biogas plant using press mud, storage yard is one of the important key infrastructure one should have. It is an additional investment, but that's an investment for the lifetime of the plant for 20-25 years. So one is able to create this storage yard. The storage yard is typically made of an RCC, the base, or an asphalt can also be used depending upon the feedstocks. And the right storage method is very important for maintaining the gas yields. And this is another storage yard picture from Germany, where maize is stored. Generally, Germany has a lot of experience in storing different feedstocks, especially maize, because maize is used as an energy crop, and maize is harvested only for 1 month in a year during that gap, which means that they need to store it and operate it for 11 months. So a lot of this know-how and experience of storage, which can be also, we could learn from the Germans, where operators of the plants there. So another thing is we always get questions on what is the gas yield from press mud, how do we determine this gas yield? So the gas yield per ton of press mud, or in general for press mud, depends upon the following factors. So the dry matter, the organic dry matter present in the press mud is one of the important key factors to work on these calculations, theoretically as well. And type of the storage method used, because if you don't store properly, there are a lot of chances that, most likely that the gas will be much lower than what would be your actual yield. So storage of press mud is very important. That's the reason we wanted to share the storage methods used across the world. And also the efficiency of the sugar mill. I mean, as most of you know that, the more recovered sugar you recover, there will be less sugar or sucrose left in the press mud for further processing into biogas. So if the mill is slightly older and, process is little inefficient, then you could get slightly more gas. And also the most important thing is the digester biological process. It all depends upon the operator and the technology provider, how the digester is designed and how this is operated, and how the whole process works. That is also one of the key factors when it comes to the gas yields. And also we will briefly go through why CSTR technology is suitable for solid substrates. CSTR is nothing but continuous stirred tank reactor, where there is a continuous mixing happening inside the digesters. Mechanical agitators, this mixing is very important for solid feedstocks. This is crucial for mixing and maintaining the homogeneous condition in a consistent way inside the digester. And this also prevents sedimentation happening over a period of time with the solids being settling down, so on. So that's why the mechanical agitator mixing system is very crucial. And just for an example, like, close to 9,600 biogas plants in Germany operate based on CSTR based technology, like, where there are mixing or mechanical agitators used inside the digesters. So these are some, briefly we'll go through non-press mud based sugar based feedstock as well, just to show that, even other feedstock, there might be participants from non-sugar based industries as well, where it might be useful for them. So I would let Dr. Hans to briefly go through this specific slides.
Yeah, thank you, Joseph. This plant is a plant in Eastern Germany near Berlin. That was the first plant I was operating starting 1998. I was responsible for the basic design of the plant at the time, and the client asked me to operate the plant later. I was operating this waste processing biogas plant for 10 years. We operated, we processed waste from the city of Berlin, a very crazy mixture of feedstocks, like the source separated organic waste of the municipality, slaughterhouse wastes, supermarket wastes, all the food in packed food in supermarket, which couldn't be sold in time, chicken blood and so on, a little bit cow manure. In total, we processed in the average about 40,000 tons of waste per year. I was operating this plant 2001 to 2007. That was the plant I really learned how to handle difficult feedstocks. The second picture, thank you, Joseph. Next slide, please. This plant is my own plant. That's a monofermentation of silage in the region where this plant is in north of Bavaria. The ground level is about 600 meters above sea. Their maize doesn't grow; it's too cold in spring to grow maize, and so we use triticale and grass as feedstock, silage of these materials. It's a dry fermentation plant with mixer. Very small digester with very high load. That was my specialty, to be able to handle the feedstock in small digester with very high organic loading rate. This plant has a heat grid to supply an industrial area there with heat, and the electricity is sold to the grid. That's a plant I made in Latvia in 2009 or 10. Can't remember exactly. It's a digestion of the stillage of an ethanol plant. The ethanol plant produces vodka from grain, different types of grain, what they get. The product is vodka. The plant has an electricity capacity of 2 megawatt. One of the challenges in that plant was to handle the quite high concentrations of ammonia in the feedstock and the sulfur. We designed the plant, we constructed the plant. I'm still consulting the client up to now and supplying the company with micronutrients.
Thank you, Hans. So now we go to the last part of the presentation, which should be more on the components used in biogas digester, so that the idea of the specific section or showing the specific section is to visualize what are the typical components involved in a biogas plant, which includes also the feedstock preparation process. So here in the first slide, what you see is a feedstock preparation happening, how the feedstock has to be stored during the harvesting. For example, this is a maize-based plant. So similar to this, we have to store the press mud and compact it and use it for the right storage. We have to use the right storage process. Then we have the feeding system. So this is what you see, the blue colored equipment is a container where the press mud would be typically loaded into this using a teleloader. And from this container, the press mud would directly be taken into the digesters via a screw conveyor, as you could see from the picture. And this container comes with load cells for measuring the press mud volume, and it can be adjusted as well. I mean, you can record the data. That is very important for recording the data. What is the feedstock which goes into the biogas plant? And what you see are the biogas digesters. The green color one is the insulation provided for the heating, in the sense like, because the weather in some countries, the insulation is required for preventing some temperature or temperature losses. What you see on top of this tank is a double membrane gas for the gas collection. The gas is collected in the top. So this is again one of the recent plans set up by our team in Germany and Ukraine before the war had started there in Ukraine. So this is one of the latest plans. Again, you can see the top view, how the digester double membrane looks from the top, and you can see the gas feeding, the feedstock container in color green, where it is used for loading the feedstock, and from here it goes automatically into the digester by a screw conveyor. So here is more automated, where there is a minimal human intervention of, moving using a conveyor and transporting and loading and so on. So these are our agitators, which we use inside the digester for mixing into the digester tank. So this is the inner portion of the digester tank, how the digester would look like. So you could see there are heating coils in the walls of the digester for maintaining the temperature, because maintaining the temperature is one of the crucial parts of gas generation. This is more critical in European conditions because of the weather conditions, but even in Indian conditions, if we look at certain regions in the north, we need to maintain the temperature during this part of the year, especially when we have winters. The gas production should not come down, so we need to use the steam and use it for heating the digester. And the mixing systems, what you can see, are used for mixing in a consistent way. And in our case, we use a high viscosity mixing system, which is specially made for semi-dry fermentation process, which is able to mix even higher viscosities consistently. And again, this is almost the same pictures. You can see the heating system, and there is a center pillar between the tank, in between middle of the tank, where this is used for holding the gas holder. For example, the gas holder on the top, there are two membranes, one for storing the air to give it a shape, and consistently the air is using a blower is maintained there. And the inner portion, of course, you can see this membranes here, but that's how it works. You have a couple of membranes on the top for the membranes to prevent them falling on the slurry or the liquid inside. Some sort of ropes or strings are given inside to not them to come in contact with this liquid. This is one of the manure pictures or the digestate pictures generated in press mud. So the press mud generated in our specific process post the digestion would look something like this. So that's what I was saying. We can prevent generation of slurry or excess liquid in the plant by adapting to this process for digestion of feedstocks like press mud. And the final thing would be the CO2 removal, because once we have the biogas after the digestion, the next step would be to removal of hydrogen sulfide and CO2. For hydrogen sulfide, of course, you can use chemical, biochemical, or biological scrubbing systems. And the CO2 removal can be done by either water scrubbing, membrane-based scrubbing, amine-based scrubbing is also can be used, and pressure swing absorption also can be used. So each technologies, depending upon the location and the available resources like heat, water. So this is based on, it can be finalized based on this specific location of the plant. So just some pictures of how a typical pressure swing absorption would look like. Pressure swing absorption, the concept is based on, pressurizing the biogas into a molecular sieve type media, and then again depressurize to remove the CO2. So pressure swing absorption is one of the commonly used technologies across the world. And also it is independent of using water technically, and also the weather conditions would not affect the pressure swing absorption in general. And also membrane-based purification system is something which has been in the market in the last few years. It's getting a little bit popular because of the compactness and the container what is being used. But again, the lifetime of the membranes is something which is also need to be looked into. So since it's a new process, so this works on the concept of passing the gas through specific membranes, where the biogas, methane and CO2 are in a way based on the membrane quality. You have this methane being separated and CO2 separated as a permeate gas as well. So then you have the final, I would say, the project specifications. Typically, there might be questions on what is the typical size of the project you would like, and what are the area and the manpower required. So we just had one slide saying that what would be the typical plant size under Indian conditions, which could be economically viable. So 210 press mud plant, to generate around 8 tons of CBG. Again, it depends upon the quality of the press mud. So we are just giving a ballpark number here. And this would require an area of around 10 to 12 acres of land overall, which includes the press mud storage, the equipments, and the manure storage. Equipments per se would not take more than 1 acre of land, but it's more about the storage, and the post storage is what is important. And then we have the plant automation for monitoring key parameters, because this is very important. And also we understand that under central finance scheme, the plant has to be automated using a SCADA system, is what we also understood recently, because it's very important to capture the data for the MNRE or the subsidy agencies to see the optimal performance of the plant, because the subsidies are subject to the conditions that plant is operating according to the proposed capacity. So automating the plant will be very crucial for various factors, not just for MNRE's sake, but even for operations and recording the data and so on. And when it comes to the timeline of a plant, a biogas plant from the start to end can be completed between 12 to 14 months time. And post the commissioning, of course, the plant needs some time for stabilization and so on. When it comes to the manpower required would be between 10 to 12 people with a very good efficient biogas plant for such capacity. And this specific slide is more on the characteristics of the press mud, because we keep insisting sugar mills now who are looking to set up biogas plants to look into the press mud characteristics and make a basic data in a nearest lab. Most of the labs are capable of doing this this type of a test. Because this is what your this is what your financials and your economic viability, financial viability will all depend upon what is the per ton of gas you would be able to generate. So it is very important to not to make any assumptions in general, because some vendor is saying, or some other client is saying, when someone is saying, so it's better to test it for your own, because from our experience, we have seen that the gas yield varies from sugar mill to sugar mill very much. So these are the basic parameters one has to test, which a standard laboratory would be able to do it. And as Mr. Sachin already explained, our cooperation with Shriji and how the model is working. So this is Shriji as a licensing agreement J&F Biogas for the digestion technology. And as you all know, Shriji has been in the industry for many years and executing boiling house and sugar mills also in various countries. So this is our typical project execution model, where Shriji will be doing the EPC and front ending, and J&F will be offering the technology and supplying some critical components for the biogas plants. Yeah, and yeah, so that was about the presentation, and we would like to once thank Shrijee for organizing such a wonderful webinar, and we would be glad to take questions post this presentation as well.
Yeah, thank you, Joseph, and thank you, Dr. Hans. That was very informative. There are a number of questions in the chat box, and I don't know how much time we have, but Joseph and Dr. Hans, please go ahead, try and do your best. Joseph, do you?
Yes, I would jump into some of the questions. If there are some questions anyone are able to pick, also we could do that. So how much power would be, this is from Bojraji. So his question is, how much power is needed to start a 100-ton press mud plant? I think he's more asking about the OPEX or the power required. So for operating a 100-ton press mud plant under Indian conditions, including CBG, you would require around 300 to 350 kilowatt per hour power required, including the purification, compressors, and everything. So that's the ballpark number. So this is the capacity or the power required. Then I would jump to a few other questions here. In a grain, this is from Mr. Gautam. In a grain-based distilleries, most of the people don't use biogas. Can we do in grain-based distillery? Please guide for a 80 KLPD grain-based distillery. So in this case, I think grain-based distillery is a I guess it's a sugar-based feedstock, if I'm right. We can do that in grain-based distillery. But we need to know the volume of like the effluent coming out of the plant. But it is feasible to do in grain-based distillery.
I think Dr. Hans is trying to say something. Dr. Hans, do you want to add something?
The grain-based biogas plants for stillage are increasing currently. Most of the distilleries using grain as basic material to produce the alcohol, they produced DDGS to sell it as cow food, for example. That was more profitable in comparison with biogas in the past. In the meantime, on account of the high gas prices, the drying of the stillage is so expensive that most of them start to think about biogas production for the stillage. And that's a very interesting option. In the Latvian plant, for example, that saved the company against bankruptcy, because that plant really made money from the stillage.
Okay. And there are a few questions on, like, what would be the better route to handle the spent wash from Mr. Patrick. So handling spent wash through incineration route or generating CBG from spent wash. So if you ask us as a biogas professionals, we would definitely say biogas, not for that alone, but also in terms of your energy efficiency, generating biogas from spent wash, provided the local, the pollution control board norms are not stringent, would be the best option. Handling spent wash to incineration, of course, there is an investment, higher investment, and also, the way, how you use spent wash as we used as an energy, for generating energy rather than incinerating it. There is also a question on what would be the minimum capacity of a commercially viable CBG plant. So, well, it depends upon the local CBG or the power prices in this specific context. So under Indian conditions, what we are currently looking at is anywhere between 150 tons to 200 tons would be one of the economical viable size. And also it depends upon how much of manure sales could happen from the plant. Because the manure could become a key factor, like, how much revenue can generate from the manure generator would be one of the key for determining the payback in the project. And there is a question on how much investment would be needed for a 400 tons per day capacity plant and return of investment. So of course we would be interested to answer this question. So we need to work on some numbers for this, and individually happily we would be able to share this. And we would definitely make note of your query here and share this query, because there are several factors involved. So 400 ton is a quite large capacity. So 200 ton plants, I can give a reference for a 200 ton plant. So 200 ton plant is cost between 55 to 60 crore Indian rupees in terms of investment. So that is a little less than 10 million US dollars. So for a 400 ton, we can't exactly double, but that gives you a ballpark number. But we'd be happy to discuss this specific case. You can, reach out to the CG sales team. We also have the emails here for, your questions on shriji@sales.com. So there was a question again from Bojraji on what is the advantages and return of investment when it comes to wet fermentation process. So typically the power consumption would be on the digester front, it would be close to 50% of the wet fermentation. So because of the less number of mixers and also other components of using decanters and solid liquid separators in wet fermentation, we would not recommend the usage of solid liquid separators and decanters. So there will be approximately around 50% savings on the digester operation side you could see when it comes to the semi-dry fermentation as wet fermentation. And there is one question from Mr. Ram Patil. So volatile solids play a vital role in biogas generation. However, after a certain period, it gets decreased and consistently reduces the biogas generation. So that's a very good question. So the question, what is asking what would happen if you keep it, store it for a longer period of time? So this is in context of press mud or any organic feedstock. you need to make a proper storage of the feedstock. Then that's the only way you can prevent the deterioration of the the volatile solids happening. And maybe I would like Dr. Hans also to answer to part of this question. The question is, if after a certain point the gas generation decreases, so that was his question. If how important is the volatile solids was his question.
Yeah, the volatile solids is the base of the biogas production. To keep this stable, especially as press mud, we make this storage as a silage. In the press mud, we get lactic acid fermentation. The pH drops down and keeps the whole material stable. It must be done in the right way, but then the gas yield is constant for a storage period of more than a year.
Okay. And there is also a question on costing for 200 tons. So we gave an idea of what would the 200 ton plants would cost, and then how to handle waste after the digestion process, please suggest. So when it comes to the waste, it depends upon the local regulations, like, whether you are allowed to handle this waste in a way, like use it as a manure, in the sense spray it on the fields in a more organized way with the proper norms in place, or it can be open composting can be done, open drying can be done. So there are different methods depending upon the feedstock and the location of the plant. So this is waste per se is an organic composition, it's an organic manure, so it's not something which is harmful. So right method has to be used. As I said, you could use a composting method, or using as open sun drying, or using a solid liquid separator if it's a feedstock like paddy straw or some other specific feedstocks, where you can separate the solids and then there is a liquid, and the liquid also can be used as a liquid manure. But currently in India, according to our understanding, there is no much market for the liquid generation, liquid based manure. There is a question from Mr. Parag: how much CFA will be available in percentage compared to the investment of the biogas plant? So that would be quickly, if I could do a calculation, so that would be around roughly around let's say 10 to 15% of the total investment can be availed as subsidy. Just as a rough calculation, I'm giving this number. And there is another question by Mr. Radhakrishnan. The question is, if we use poultry litter for biogas, will ammonia play any role, and how to eliminate the ammonia in biogas? So I would let Dr. Hans to take that question. That's related to ammonia in poultry, Dr. Hans.
Yeah. Poultry litter has a high amount of ammonia. To digest poultry litter as mono feedstock seems to be impossible. It's a very interesting co-feedstock for example, press mud, because press mud is low in nitrogen, and the bacteria needs a little bit amount of nitrogen for growing. Therefore, a mixture of press mud with poultry litter is an interesting feedstock mixture for biogas plants.
Okay, so I think what Dr. Hans was saying is poultry litter can be co-digested with press mud, so that balances the required, the ammonia can be in a way handled to some extent, but there is a proportion of, if you take 100 tons of press mud, you can add another 10 to 15 tons of poultry, and in a way poultry available like in a large volumes as compared to press mud. So co-digestion in a right proportion would be one of the best ways to handle it. And there is also a question on the gas purification systems. In general, what is the membrane life in this kind of gas application? See, membrane is a new technology. To answer to the question, membrane is a new technology which has been used in the last few years. According to our understanding from vendors, we understand that membrane would have a lifetime of 6 to 7 years. But that again depends upon how efficiently the plant is operated, how efficiently the membrane is handled, the quality of the gas, and how do you remove the CO2 before how you remove the hydrogen sulfide before the gas CO2 enters, CO2 plus methane enters into the membrane. Maybe Dr. Hans would throw some more light on his experience of membranes usage in Germany and other European countries.
Yeah. In Germany, we started in 2007 with the biogas upgrading to natural gas quality with several technologies, amine scrubber, water scrubber, pressure swing adsorption. Later, the membranes come on into the market, especially for smaller plants. The membrane is an interesting technology. A little bit problematic is the electricity demand for the operation of the membranes and the lifetime of the membranes. But it's a proven, in the meantime, it's a proven technology. I have some other questions I would like to answer here. There were some questions about the digestion of vinasse, spent wash, and bagasse. We made tests with bagasse. Bagasse, in the principle, is a quite interesting feedstock for a biogas plant. But the question is it more profitable to incinerate it and produce steam for the sugar production or making biogas? I think it's better to incinerate the bagasse. It's more profitable than to make biogas from it. With vinasse and spent wash, I'm sure the digestion of the spent wash making biogas and energy and use the digestate as fertilizer is the much more environmental friendly way to use the spent wash instead of incineration. And it's no problem to digest the spent wash or vinasse, it's the same material. The only problem is the high concentration of sulfur in the spent wash, but that is we can handle in the biogas.
Okay, and one question is on what is the moisture content in the raw gas and what is the permissible limit and how can the moisture be removed? Again, I would like Dr. Hans to answer this. The question is how do you remove the moisture and typically what is the moisture percentage?
So the biogas is produced in the digester with digester temperature, for example, 50, 55 degrees centigrade is thermophilic digestion. So the gas coming out is water saturated. To give you a number, in the volumetric biogas, about 17% is vapor, water vapor. And if you condensate, you have some liters water in the biogas. The way to remove the water is quite easy. We cool it down to 5 degrees centigrade and most of the water will condensate and we can put it out and give it back into digester. The way to clean up the biogas is first cooling down, remove most of the water, then, for example, an activated carbon filter to remove the H2S. In this activated carbon filter, we have a way to increase the lifetime of this filter drastically by in situ regeneration of the filter.
Okay, and the next question, I would take a little bit more questions on the purification side as well. So in a gas purification system, the membranes are operated in how many stages? Typically there are 2-stage membrane and 3-stage membranes. If you want a higher quality purity of methane, you could use a 3-stage membrane, which is around 99% plus methane can be obtained by using a 3-stage membrane. That's typically what is the standard design offered in European countries and Germany. But in India, we have 2-stage membranes also been offered. The reason being that according to the norms of like the CBG generated, the minimum methane percentage required is around 90% for the offtake for the oil companies. So, but still, I think 95% is something which has been adopted by most of the technology providers. So the stage depends upon the quality of methane required. But a complete plant would work something like a 3-stage membrane to give a 99% methane. Then that's one question from Mr. Hudson. So how is the biogas handled when pressurized to 250 bar pressure? When it comes to 250 bar pressure, I would say that this specific solution might be more specific to countries like India, where there is no gas grid. So what happens is in India, we have to pressurize at 250 bar pressure because we have to compress that into cascades or cylinders for further transportation. With this specific pressure, you can transport more gas and take it for a longer distances. But what happens in countries like Germany, Sweden, and other countries is there is a gas grid. Like, when there is a natural gas grid next to the biogas plant or nearby the biogas plant, you can inject this gas at a much lower pressure, around 5 to 10 bar pressure, into the natural gas grid pipeline. So you can eliminate the use of these compressors and cascades. Typically, a biogas plant should work this way, where you inject into the natural gas grid, where you don't have to use this cascades and compressors, which is an additional investment and the compressor consumes a lot of power. So compressors are one of the main power guzzlers in the biogas plant. So yeah, if there is an opportunity, it should be injected into the grid. And also in India, some plants are coming up where the biogas is being planned to injected into the grid. So there is one question, Mr. Hari Sansari. How much time a digester can sustain if there power cut or there is a blackout? Hans, you want to take that? How much time can it sustain, or should the emergency power be part of the standard design to prevent that happening?
What's happening? I didn't understand the question.
Okay, the question is, how much time can the biogas plant sustain, in the sense operate, if there is a power shutdown, for example?
Okay, if there is a power shutdown, it doesn't matter because the biology will work. But I recommend to have an emergency power unit to keep the plant operating, small one, just to keep the mixer mixing and the SCADA working, to maintain damages technological damages in the biogas plant. The digester is no problem. The bacteria will alive months.
Yeah. So the answer was, what Dr. Hans was saying is, you should always have and design a plant with like an emergency power to back up the critical components. The digestion would still happen, for that specific time, but to have a consistent mixing and everything, you can have a backup power. And then there is one question from, sorry, Hans. Yeah.
Yeah, there was a remark from Evonik from Germany as leader on the membranes. There are some companies worldwide, even from India in the meantime, providing such membranes. Evonik was the first one providing the membranes for the upgrading, but Evonik don't make the upgrading plants. They only deliver the membranes and sell it to the packager which designed the upgrading plants.
Okay. And there is one question from Jayan Sharma ji from Uttam Sugar Mills. Whether the digestate can be sold as it is a manure or any further treatment is required. So that's again like, very good question on how to, have the optimal value out of manure. So the manure per se, what comes out, the digestate, it's a very good manure, but most of the established manure companies today, as we know that, many sugar mills don't package. I know that, for example, Uttam Sugar is already working on it. They're making a potash fertilizer as well. But, you are one of the pioneers in selling this manure. But in general, many sugar mills don't even sell the existing press mud per se. There are many vendors, contractors who take this from the sugar mills and then they resell it at a much higher value, which the sugar mills directly are not doing today. So there is definitely a value for manure. We could always add some additional additives, minerals into this manure to meet the required. Each and every crop has its own requirement on NPK proportion. So this can be always optimized by mixing, for example, with poultry litter, as Dr. Hans was saying earlier, or with some minerals to optimize that. So there is definitely good value for this across the country, because most of the food we are being, the manufacturers are more leaning towards organic food and so on. So this would definitely play a crucial role. And there was one question again from Mr. Radhakrishnan: what would be the proportions of press mud and poultry litter? I think, Dr. Hans, if I'm right, it could be in a proportion of 90% to 10%, 10% for poultry. Would that be right?
I would calculate this individually on account of the analysis of the poultry litter. But with press mud, up to 10% could be possible.
Joseph? Sorry, go ahead. Sorry, Dr. Hans.
There was one question about the desulfurization of the biogas. Avantgarde asks about 25,000 ppm H2S in the biogas. We will get 25,000 ppm H2S in the biogas by digestion of the vinasse or spent wash. And to remove this, we use a multi-stage reduction technology for the H2S. That's a challenge. It's possible, and it's a challenge. We did it in Brazil. It's a multi-stage technology. It's possible, and it's, to be honest, it's no problem, but it costs a little bit more investment.
So Joseph, I wanted to just point out Mr. Ristrianta's question, which was somewhat related to the poultry litter. For feeding to digester, can we mix filter cake with rice stalks and leaves? Can we mix filter cake with rice stalks and leaves?
Okay, Hans, the question is, can we co-digest straw and press mud, for example?
Oh, that's a little bit difficult. Yes, it's possible. I cannot say a number today. It depends on the pre-treatment of that rice straw. It must be milled very fine, and we will get a very high viscosity in digester. So that the plant must be changed a little bit in comparison to a monofermentation of press mud. We will need recirculation of liquid and separation then in that case for sure. But the gas yield of the rice is very interesting and it's possible.
Okay.
Even the same is cane trash. Cane trash is also an interesting additional feedstock for a biogas plant. Very interesting.
Okay. And there is one more question on the storage again. As we explained, during the how much storage impact will have not proper storing on the biogas yield. So storing, or if any preservatives are required, is the question from one of the participants. Hans, do you want to take that? Like, do you recommend any preservatives? Because that's something in India, a lot of them keep discussing using preservatives for enzymes for doing biogas.
Yeah, let me answer in a standard way. To optimize the biogas yield, many technologies are promoted by the sellers of the products. You can use enzymes, you can use steam explosion, you can use some crushing technologies, especially for solid feedstock like straw. You must crush the feedstock maximum fine to help the bacteria to produce the biogas. Enzymes also will help for some feedstocks, for example, straw. Enzymes are not necessary for the press mud because the press mud is a very easy to digest feedstock. What each biogas plant will need is micronutrients, because there is always a lack of biological available micronutrients in the feedstock. The micronutrients helps the bacteria to produce their enzymes to produce the biogas from the organic material. Did this answer your question?
Yeah. Okay. Thank you, Hans, for that. And then there is one question. Can we operate? Okay, before that, I'll take a question. For paddy straw, which pretreatment method would be used? Or that was a question from Lenovo participant. Yeah. Which pretreatment for paddy straw would be recommended? Yeah, would that be mechanical pretreatment, hammer mill?
There are some pre-treatments on market. We can pelletize it. We can use a hammer mill. I used hammer mills. I just currently I'm testing pelletization. The milling or the destroying of the physical structure is of course necessary. I made tests with steam explosion to increase the gas yield. This will work, but the profitability is a little bit critical on account of the investment and the steam demand for the steam explosion. You can use enzymes. Currently, I'm making tests with enzymes in my own plant. I have experience with enzymes since about 15 years. All the suppliers promised me the gas yield will increase and the use of the enzyme is profitable, but I never measured the increase of gas yield in my plant. So I try it with straw in the meantime. Let's see what happens.
Okay, sure. And then let me take a few more questions. Can we, from Dr. M.S. Sundaramji, can we operate filter cake during the season and use the same digester for alternate feedstock during the off season? Yeah, I mean, this was something we discussed during the presentation that, it is better to use filter cake along the year because when we talk about alternate feedstocks, it depends upon their availability. So you can always use the storage method for preserving the press mud and proper storage. And during the off season, you can technically, of course, use an alternate feedstock, but there will be a change over time, which would happen when you're changing from one feedstock to another. I assume, Dr. Hans, I don't think biologically, what would be the challenges of running press mud for say 6 months and running paddy straw for 6 months in the same digester, just as an example. I mean,
yeah, look, the bacteria in the digester will adapt to the feedstock they get when the startup of the plant occurs, and they will be trained on that feedstock. If you change it, they can do their job in a worse way. So they will reduce the gas yield and so on. And if you change it each half year, they have no chance to follow because the adaptation period is a half a year, something like that. So I recommend not to change the feedstock too drastically. You can do it step by step. You can make a feedstock mixture. You can change the feedstock, but not each half year. I urgently recommend this not to do.
Okay, thank you. So the answer from Dr. Hans was that, it's not preferable to change the feedstocks to maintain a certain consistent feed in the plant. And I would take one question from Mr. Neil. His question is it good to burn cane leaf or digest brown leaf? I think he refers to the cane leaves, I understand. So it's a combustion or the digestion is a question here when it comes to cane leaves. Maybe in terms of technology, Dr. Hans would be able to answer, but part of the answer could be that it depends upon the economics, like, what is by burning or combusting, how much you make, and from selling the gas, how much you would make.
I didn't understand what the question means.
The question was the cane leaves or the cane trash. Is it better to burn it? I don't know. He meant, I mean, the question was a little open, so he was asking burn. So I didn't mean. I understand burning might be in a combusting in a boiler, for example. It's better to do that or to generate biogas.
For cane leaves and cane trash, I would recommend use it in the biogas plant. For biogas, I think incineration, burning in a boiler is better. The reason is biogas is pressed. Most of the organic material, the easy to degrade, biologically degrade material, came out. In the leaves, all the cellulose, hemicellulose is in, and the gas yield is very good. Biogas is difficult to handle. It's dry enough to use it in a boiler, and it's very easy to handle it. Therefore, I assume even under Indian conditions, the incineration of biogas is more profitable than the biogas plant, and the digestion of leaves and cane leaves is more profitable in India instead of burning it.
Okay. But if Mr. Nail meant by open burning, of course, burning is much more worse. So it's better to digest it. Like, a lot of farmers do burning in the field to clear the cane leaves, for example. And one question is, what is the typical maintenance required in a biogas plant from Mr. Avinash Bhatt? Hans, based on experience of operating plants, do you want to share an answer for this? The question is, what is the typical maintenance service required in a biogas plant?
Okay, I can tell about the maintenance service in biogas plants in Germany. Let's take the standard biogas plant in Germany, producing the biogas and using the biogas to produce electricity with an CHP. About 65 to 70% of the maintenance costs per year is the cost for the service of the CHP in that case. And only 30% is mixer, pumps, and so on.
So by CHP, by CHP, Dr. Hans means the biogas engine, actually combined heat and power engine, which is commonly used in Germany. Yeah. Please go ahead.
Yeah. To give numbers of my own plants makes a turnover of around about 1 million euros a year. The service and maintenance cost is about 10% of this, 100,000 euros, and 70,000 is the CHP, the oil, the sparks, and so on. If I use a biogas plant with biogas upgrading, the situation changes depending on the upgrading technology. Then the portion of the costs for the upgrading is lower than the CHP. It's good technology, but all the biogas plants with gas upgrading and injection to the grid are much bigger than the CHP plants. Normally, they are 3-4 times the capacity of the CHP plants, so it's not really comparable. In that case, the costs in the operation change to the costs for electricity for operation of the biogas upgrading.
Okay, I would just give. I'll take last couple of questions and probably we'll just end pose that. So there was one question generally saying, can we mix filter cake with the rice stalk and cane leaves? I think that was already answered. Depending upon the pre-treatment, we could do that. I guess that was the answer what Dr. Hans gave. And there is one more question on maybe the last question I will take. What is the dry matter inside your system? Hans, you want to take it? I assume it depends upon the feedstock.
Yeah. In the case of press mud, we will get about 18 to 20% dry matter in the digester. This is quite well mixable with our high viscosity mixing system. If you would mix, for example, cane trash or paddy straw along with the press mud in the digester, the viscosity increased so drastically, so you must reduce a little bit the dry matter in digester to 15 to 70%. That's the number I'm operating in my own plant with the triticale silage. So that's the standard. If you would use a wet fermentation plant with the mixing system of a wet fermentation plant, you must reduce to less than 10% to keep it mixable in a digester.
Okay, so
I guess that's it, I think. Thank you.
And there is one such a final comment from I think one of the Germans, Mr. York. So really pleased about the presentation, real expert. Thank you, Mr. York, for your encouraging words. So it comes from the biogas expert. Yeah.
Yes, I want to say danke. And also danke, Dr. Hans. Thank you so much for your time. Thank you, Joseph. Thank you to all the participants. Great turnout. Thank you for your enthusiastic participation. Shriji is very excited to work with JNF Biogas. We welcome your inquiries. Our goal is to build a world-class biogas plant for you. So please reach out to us, and thank you for your participation. Thank you.
Thank you very much.
Thank you. Thank you, everyone.